Okay, guys, here we go. This is week 3, lesson 1. Now, again, we're reviewing just like we did for the past couple of weeks. What we're doing now is we're going to look at parabolas. Again, we're just going to touch on a couple examples, kind of remind you how this stuff works here. Remember parabolas, what we're going to start out with is there are U's, right? They're either going up or they're going down. Right, that's where we start out. We're going to end up going left and right, but we're starting here with our parabolas that are U's. When we graphed our parabolas, we had a couple key points that we looked at. We had this point inside. That would be our focus, right? And then we had that line on the outside, which we called the directrix, right? Now, that focus and that directrix, it told us a lot about our parabolas, right? We could find the focus and the directrix because they were equidistant from the vertex, just as every point on the parabola is equidistant from those two places. But what we could find from the equation was this distance right here. That distance from the vertex to the focus that we called C. I'm going to say C equals vertex to focus. So really all we had to do was find out what was this value of C, and we could go through and do these graphs, right? So we're going to jump straight into it. We're going to do a couple examples here. I tried to have it set up and be a little more organized. We'll see how this goes. So we're looking at this first example. Y minus 5 equals 1 over 8 x minus 2 squared. The first thing is we know we're doing a parabola because it just has one of our variables squared here, right? Just the x is squared, where when we had circles, something like equals 16, both the x and the y were squared. Since we don't have both of them squared, that means we're doing a parabola. The first thing we have to do, though, is get that y by itself, the one that's not squared. To do that, we're just going to take 5 and add it to the other side, right? Giving us the equation y equals 1 over 8 x minus 2 squared plus 5. Now, just like we did for circles, how it told us the center, the equation for a parabola, once we get into this form right here, tells us where the vertex is, right? We call this our vertex form. We can look at this and identify our vertex just like we did for a circle. So what you can do is we look at this and we're really just curious about what's attached to our x first, right? We have minus 2 for our x, right? Which is telling us we do the opposite, right, when it's in parentheses, to go right 2. So that x value is going to be a 2. Now, where it's a little bit different from circles is when we look at this, plus 5 on the other side, we don't think opposite here. I'm going to say don't make opposite, right? So that has to be telling us our y value, right? So what it's telling us is we need to go up 5. We don't make it the opposite, so our vertex is 2, 5. Now, when you have that, we can go on and graph our vertex. So right 2, up 1, 2, 3, 4, 5 puts us right there. That's where our vertex is. That's the first step. Once you get the vertex, then we need to find the focus and the directrix. Now, to find the focus and directrix, we kept setting up this specific fraction, right? What we know is this fraction out in front here, this 1 over 8, is giving us a lot of information. We can set up 1 over 8 equals, and every single time we use this 1 over 4c. That's just how these equations worked out for us, right? We could always set up that ratio and find out what c is. So all we have to do is cross multiply. 8 times 1 is 8 equals 1 times 4c is 4c. We can solve that for c by dividing by 4. We get c equals 2, which is important. Again, that's telling us a lot. C is telling us how far we need to go from the vertex to the focus. Now, we know that this parabola is opening up because it's a y equals, right? That's what we're dealing with. We know that the distance from the vertex to the focus is 2. So, since it opens up, we know it's a distance of 2. We're going to go from the vertex, we're going to go up 1, 2. That point right there is our focus. We can write that coordinate point. That's at 2, 7. Right? Now for the directrix, it's equidistant, right? It's the same distance from the vertex as the focus is. So if we went up 2 for our focus, from the vertex we're going to go down 2 for our directrix. Now it's not a coordinate point. For our directrix, we're going to draw a dotted line, or a dashed line, sorry, right here. That's our directrix. When we are writing our directrix for our answer, we have to represent it as an equation. The easiest way to do this is, our equation is y equals. So our directrix has to be y equals. And then you just look at, what does y equal for that line? We go up 1, 2, 3. So that's a directrix of y equals 3. Right? That was all the information we can get from a C there. The last thing that we can find are these focal chord endpoints. Right, now to find the focal chord endpoints, there's a couple different ways of looking at this. Right? This is the focal width form here. Since it's 1/8, it's telling you that the width at the focus is going to be 8 wide. So you would go 4 to the right or 4 to the left. If you don't remember that, we could always set up 2 times whatever C is. Right? So then we already know that C is 2. So we're going to go 2 times 2 equals 4, telling us right 4, left 4 from the focus. That's the main thing. We're going to go right 4, 1, 2, 3, 4, left 4, 1, 2, 3, 4. From the focus, those are your focal chord endpoints. And with all of that, we can graph the parabola. So it goes through the vertex, through those focal chord endpoints, and it should end up looking something like that. Right, that's the graph of our parabola. Now the last thing we have to do is just state what our focal chord endpoints are. So let's go ahead and say this is at what? 1, 2, 3, 4, 5, 6, 7, and the second focal chord endpoint is at -2, 7. Right, now that's all the information that we need to get through, and you have to be able to get to a graph like that. We're going to look at one more. We have one going up, so we're going to look at one going down. We're going to go through it a little bit quicker here, so we don't have to sit here and listen to me talk for a long time. Again, we look at this. The first step is you identify which way does it open. It's y equals, which means it's opening up or down. Since it's negative, I'm going to say it opens down, right? The second step, you want to get that variable by itself. It's done. We already have y by itself. We can move on. Right? Now we want to find out what the vertex is. And again, this is where a lot of mistakes tend to happen. Right? When we look at this equation right here, it's kind of challenging to think of the vertex. But we can rewrite this again as -1/12. Since there's nothing attached to the x, we could think of it as x plus 0 squared plus 4. And again, that right there will tell us everything. We can now find what our vertex is, right? We look at this 0 for x. Don't change anything about that 4 on the outside. That stays the same, not the opposite. So our vertex is 0, 4. So 1, 2, 3, 0, 4 right here. After that, again, we're going through these same steps, right? We want to find the focus. We want to find the directrix to find our focus, right? We set up -1/12 equals 1/4c, and we can solve that, right? So we end up with 12 equals -4c. It's okay if it's negative. Divide by -4, we get c equals -3. What that's telling us is we know it's going down. So that means for our focus, we have to go down, right? So we go from our vertex. We're using that distance of 3 that we just found. Since it opens down, we go down 1, 2, 3. This is from the vertex. That's your focus. That's at the coordinate point 0, 1. Again, to find the directrix, we do the opposite. So instead of going down 3 from the vertex, we're going to go up 1, 2, 3, and we end up here. That's our directrix. Again, for our directrix, it's not a point, it's a y equals, and we just say, what does y equal there? 1, 2, 3, 4, 5, 6, 7 is that equation for the directrix. And then again, the last thing we have to do is figure out how wide it is. Again, you can look at that distance. Oops, sorry, I'm trying to. You can look at that 12 right there telling you it's 12 wide, so you would go right 6, left 6, or you can always do 2 times whatever c is. In this case, c is -3. 2 times -3 is -6, which is just telling you go from the focus, go left 6, 1, 2, 3, 4, 5, 6, go right 6, 2, 3, 4, 5, 6. Those are your focal chord endpoints. Now after you do that, again, we can graph our parabola. We can graph it, right? So you just go through the vertex, out through those focal chord endpoints. Make sure you put the arrows, meaning it goes forever there. That would be the graph of your parabola. To finish it off, write the focal chord endpoints as coordinate points. That's at 1, 2, 3, 4, 5, 6, 1. And the second focal chord endpoint, I'm assuming, is -6, 1. Again, you need to be able to find that information, the vertex, focus, directrix, and the focal chord endpoints. That was our process of graphing these parabolas. Those are our up and down parabolas. The next lesson will be on our parabolas that open left and right. But if you understand this process of finding the c value and the vertex, it's the same process. If you have any questions, again, please let me know, email me, and we can work something out where we can work together.